Next, I'd like to talk about the object-image relationship for an actual diverging lens. Here I have a diverging lens. It's placed in front of an object here. This is what the object looks like. It's a light globe with a little arrow on it. And we're going to let the light shine through the lens and see what the image looks like as we look through the lens toward the object. Now the diagram for that is here. Here's the diverging lens, thin at the center, thick at the edges. Virtual focal point here. And we notice with array diagrams we can locate the image at this position. Notice that the image of the object in the case of the diverging lens is always going to be smaller than the object. It's always going to be erect, and it's always going to be virtual, and also it's always going to be closer to the lens than is the object. Now let's demonstrate that by having the camera take a look through the lens at the object. As the light from the object passes through the lens into the camera, we'll see what the camera sees looking at that object as it sees the image of that object through the lens. Now we have an object here, and we notice that the object has the arrow pointing up, so we can keep track of the orientation of the object. And when I move this diverging lens in front of the object so the camera looks at the light coming through the lens, it sees that virtual image. Notice that the image is erect, reduced in size, and virtual. Now if I change the relative distance between the object and the lens, watch what happens. As that distance shortens, the image comes closer to the lens. As the distance increases, the image moves further back. All the time remaining virtual, erect, and reduced in size. There's the object, and there is the image for the diverging lens.